Good morning and welcome to everybody. Thanks to X.Org board and Software for Public Interest Foundation who hosted us today for this tech talk. And today we are going to have a look at the Android x86 status with information provided by lead developer Chiwei Wang, and an overview of the graphics stack evolution in the last year. My name is Mauro Rossi, and I participate in the Android x86 forum and community. I'm not belonging, let's say, to corporate companies working in Linux open source. So I started as an hobbyist. So just as an information, I am not skilled, let's say, as the most of you. And this has been, for me, an occasion also to learn. And also learning is my prize, let's say, in participating in this forum and project. Let's start. So we are going to have a first part where we will talk about the Android x86 status, having a look at the project origins, some information from the analytics, Google Analytics, and some information about the activity performed, the porting proceedings, mainly conducted by Chiwei Wang, and some information about how external developers, contributors can help to add support to new hardware. And we will have a look at the stable and development release status, and then to future plans. So what is Android x86? So its most simple definition is it is a board support package, and it targets generic platforms, including desktop and laptops where other projects had dropped those devices. And it is an effective desktop OS alternative, despite you may think it's born for tablets and mobile devices. And it has, let's say, a mouse click as a touch user experience from the point of view of the user. It is completely open source, and it's also tracked as a Linux OS in DistroWatch. And the project was started in 2009 by Chiwei Wang and Hee-Soon. Code name is Byung. And this is it. And having a look at the analytics, we are seeing that there is, let's say, our customer base, let's say, which are the users who download the image, and install it, and try it, is constantly growing. So as a matter of fact, at some point, the Google Analytics ceased to be available to us because there were two data. So it becomes like the size of a vendor, let's say, project. And we can account for 3 million downloads in the last 2 years. And looking at some of the statistics, so we have an average session duration of about 18-20 minutes. And here there is a cumulative number of users, and there is information that there is, let's say, a percentage of new user of around 24-25%. And these are some statistics to show that there is some usage, let's say, for this operating system. Now, moving to what are the activities, they are mainly led by Chiwei Wang. You can see a photo here. And as a board support package, it uses most of the ASP Git projects. Then there are projects that were modified, so in the Android-x86 code base, most in the device, generic x86 and common, and in Surface Flinger, and in the hardware project, system core and kernel. Then there are some specific Android-x86 projects, mainly the installer for the ISO, and some part of a graphics stack, so DRM gralloc, libdrm, Mesa, LLVM. So these, of course, are, let's say, imported from the mainstream projects, and we keep updated versions, let's say, to get new feature corrections. So these are the three main group of projects in the manifest of Android-x86. So our development cycle is, even if there are not many people, let's say, working officially, let's say, on the project, and so we are low numbers of contributors, so we are agile by necessity. And so what Chiwei does is basically has a set of patches which gets rebased onto the OSP new releases. Usually the rebase is done on the latest tag of an Android version in order to get the most updated patches and security updates. And then, so basically, it's a trial and error process by definition. So basically, change code, build, test, bug fix. And one of the most critical parts has been and still is the display. Talking about, we have had been some workshop discussion on continuous integration. So what is the status in Android? As of this moment, most of the tests are done manually by people. So Chiwei Wang, me, contributors in the community. We receive somehow many times unprofessional bug reports, so done by people, normal people using the OS on their hardware. And then we try to manage them the better way we can, let's say, based on our, let's say, skills and resources. Then it was very interesting having a discussion about CI tools in a workshop yesterday. And we need, so we understand we need some CI tools which needs to be effortless and to help us in build, boot, and perform graphical user interface tests. Then we don't think, let's say, too gorgeous, because we most probably never move to continuous delivery or continuous deployment. But CI tools, I think is achievable, and it's a step we should do. And this is some information about the different drivers, let's say, are recognized and initialized. And we have an init shell script, and while the the EOSP, usually based on init.rc. And this initialization, let's say, allows, for example, to select hardware abstraction layers based on the detected drivers. This is done very, let's say, the old way with by using shell script commands. And basically, the new hardware support require Linux kernel support as a prerequisite, and then to change some line of scripts in the init hardware abstraction layer function. So, for example, in order to add a new support for a new Bluetooth device, people need to add some line with a case for the specific device name, and then add some line for doing the settings. And this is also an occasion, let's say, to speak to the audience. So you are, let's say, very high-level skilled people. But also the purpose of this presentation is also to provide some information for, let's say, end user, enthusiasts, and people participating in the community. And anybody, let's say, developer with any skill they have is welcome to extend the hardware support. So I invite you, if you have some interest, let's say, you may find some time, or you like to play with this, to participate and provide your patches if you are interested in this. Now, moving to the stable and development releases. So the current stable release is Nougat X86. It's based on the latest Android 7. And it has support for 32 bits and 64-bit systems. It's based on the previous LTS kernel 4.9. It's KMS enabled for managing, let's say, display. It has 3D hardware acceleration, and in the stable it's based on DRM gralloc. And as we speak, we are, let's say, naming as supported Intel, AMD graphics card, and NVIDIA. The ISO can be booted as a live CD, or it can be installed on a disk. And in Nougat X86 release, hwcomposer added a feature to auto-update an already installed Android x86, also supporting upgrades from previous versions. And the ISO so supports both BIOS boot and EFI boot. Then there is support for common, say, legacy hardware, mouse, Wi-Fi, Ethernet, audio, Bluetooth, and some sensor, but sensor is not covered, let's say, as per mobile tablets. So it's more focused on laptops and desktops. Then hwcomposer has, over the time, maintained a procedure, let's say, to auto-detect drivers and load the modules in the early boot stage. And also the virtual machine installation is supported with QEMU, VirtualBox, and VMware. Moving to the development release, which is Oreo X86. So it's based on the latest code base tag, or at least it was at the moment when I prepared the presentation. Then the kernel there is currently a work in progress, but is not published yet, with kernel 4.17, and hwcomposer and Vulkan also work in progress. And hwcomposer and some other developers are helping are working hwcomposer on HDMI audio support and on accelerated codecs, and also on Lineage OS integration. Lineage OS is a fellow, let's say, Android-based, Android-x86-based distribution. So this is the current status for the stable and development releases. And I will go very quickly, but here, basically, from the top, the most important features, let's say, from user experience point of view: display, audio acceleration, audio Wi-Fi, and Bluetooth sensor, camera. So something in this area, when you use it at home, let's say, they are low priority. Then, regarding the future plans, so we are trying to embrace the CI culture, but one step at a time, and then release an hwcomposer, Vulkan-enabled ISO for atomic and working drivers, so only after having tested them. And then there is an effort to improve the other codec support, let's say, for video. And then the porting of the Android P 9.0 release code base to X86. This is a list, let's say. I didn't divide between people, let's say, directly involved in the project and people who supported the project as external contributors. But basically, these are all the people who helped us in a way or another, either mailing list, information sharing, collaboration. So I like they are depicted all together because let's say the result comes from the collaboration, basically. And then, as the last slide of this part, we want to call all enthusiasts about Android GUI OS. And it is, let's say, an ideal platform for all the hardware. It could be useful also in schools, university, for teaching. And in many cases, games and controllers works out of the box, which is a nice feature. And anybody with some Linux experience and passion can contribute to extend the hardware support. Okay, I have to ask you a favor. For any questions about this part, I suggest you direct it to the mailing list and forum, because it's the best way to get let's say, the correct response. Because I'm quite limited, and I'm working specifically on the graphics stack. So that's it. We will move. But anyway, for any purpose, people interested, so you will have contacts. I will give you contacts if you need to contact Chue Wang. Okay, let's move to the second part. And we will have a look, an overview to the OSS graphics stack in Android-x86. And then starting from the legacy, the DRM gralloc with supported hardware. Then some overview about DRM hwcomposer, GPM gralloc, hardware abstraction layers with some test results. Then a little journey in the story of bringing AMD GPU support in Android-x86. And then we will deep dive in some Vulkan AMV information about build integration and testing. So for many of you, let's say, for the people who are involved in AOSP, this would be like no-brainer, very simple information. But again, here, also the purpose is to show to people who are interested, let's say, what does it take to integrate a Vulkan driver so in android-x86. And so this presentation is for you as an audience of developers, but also to the, let's say, the common baseline of people who may be interested when these slides will be published online. And then we will have a live demo with Vulkan in our X86 with Hardware Composer 1. So the legacy graphic stack is based on DRM gralloc, and Surface Flinger as a fallback option to work without Hardware Composer. So in this case, it will deal directly with DRM gralloc. And you can see here the stack from hardware to kernel layer, hardware abstraction layer user space, and Surface Flinger in the framework. Thanks to Robert Voss for providing, let's say, the picture for starting, which I have modified. Many thanks. And we can look side by side at the legacy versus Hardware Composer reference stack. So in this case, Surface Flinger enables the Hardware Composer API, and DRM Hardware Composer is, let's say, one of the open source implementations of DRM Hardware Composer, because usually these hardware abstraction layers are closed source binaries. And there is, I don't know if you know, but there are other open source software implementations of Hardware Composer. So one of them is the inter-architecture Hardware Composer, and which works on top of mini-GPM gralloc, the Inter version. And there is also another Hardware Composer, which is, again, by Intel, which is called hwc. And, it is important, let's say, to have different implementation, because then you can have a look when you have issues at how other people have implemented things. So in the end, so as far as I know, there is a DRM Hardware Composer, inter-architecture Hardware Composer, and from Intel also this old not maintained hwc. Here we have an overview of the capabilities of the gralloc implementations. So DRM grallocs, we support API 0. It has support for gem F-link names. Then regarding prime FD, it was, let's say, it had in the roadmap to become able to support prime file descriptors, but it is incomplete and untested, and in this moment is not working. And it does not have support for binderization, which is a feature that was added. So I'm going into this path just for you to understand better. So while Hardware Composer, so binderization is supported by Gmail gralloc and also prime FD. So while gem F-link names were not in the objectives let's say, of the requirement of GBM gralloc. GBM gralloc, so I forgot to mention, is a project, let's say, led by Rob Herring, and it is in his GitHub. And in my humble opinion, this project should be upstream in a free desktop org suite of projects. And then moving to the last, mini-GBM. Mini-GBM, there are, in reality, two versions. One is from Intel and one is from Chrome OS. And they are, let's say, a little bit more advanced compared to GBM gralloc in terms of capabilities. So they support gralloc API 1. Again, I don't think they support the GMF link names. But in case I am wrong, so anytime you see something wrong in the presentation, just tell me. I will correct it, amend before publishing. And then it has PrimeD support and binderization. This is the level of current hardware support for the legacy DRM gralloc. You can see, so Intel, AMD, NVIDIA, VMware, QEMU Virgil. Among Intel platforms, the Atom with PowerVR EGP are not supported because there is no open source drive implementation. And the information highlighted in yellow are the changes in our Mesa project compared to the mainstream. And there are some patches we need to apply. So in order to avoid crashes, so for example, we need to have null pointer guards to avoid Play Store crashes. Regarding AMD, we don't need to do too many changes, let's say, in the Mesa code base. Probably just one. And for NVIDIA, we have some issue because we found that Nouveau, let's say, does not tolerate too much multi-threading. And so some mutex locking patches are, let's say, maintained in the code base, because without them, the Nouveau driver would be completely unusable on Android-x86. And then, as a fallback for unsupported hardware, Sweet Shader was integrated by Chiwei Wang in the code base. Now, we have a list of contributions. I will go very quickly because we don't have much time. So basically, there were some changes to cope with the some changes in Mesa, and the most important thing is that I am personally involved in verifying no regression testing in DRM gralloc. So I am like the night watch for ensuring that there is no breakage in Mesa, in Android build, and that everything is still working with DRM gralloc. Then, speaking about DRM outer composer, outer abstraction layer, so we are listed the enablers. So we, as a mandatory dependency, atomic display framework is required. As an enabler, also explicit fencing using API from Gustavo Padovan added in kernel 4.10. Then, of course, DRM outer composer, project started by Sean Paul and now led by Robert Foss. and GM gralloc with primefd and bandarization support by Robering. And then also the smart move to move the gralloc handle structure, having it harmonized in libdrm project, so by Robering and Robert Voss. And also what was actually solving a lot of issues, so, and also allowing boot, was the change in Mesa, let's say in EGL Android, to have support for prime FD. Now we are moving to a section where we present the result of the tests. Tests and incidents, let's say, happen during the tests. So don't be scared, so we will see strange things now. So this is what is the result of the first boot after the build with all the stack. And so it was basically a black screen with the white cursor at the top left. And this affected Nouveau, AMD GPU, with AMD DC. And in Intel, there was a boot animation, but then there was a crash loop. So the GUI was not working properly. So going to dig, let's say, into the code base, and also in the Android IA DRM other composer branch. So I discovered that there was a Jimbish commit addressing this problem. So in the top part of the screen, you can see that there is an error. It is not possible, let's say, to create a display pipe to the display, and there is an error, no device. And basically, in this cycle, what happened before this change is inspired by Jimbish working in Intel. It was that for any not connected display, which it may happen on desktops, you can have different connectors, different displays, was that basically the code was jumping to returning no device error. So by adding this code, let's say, not by doing, so basically grabbed it from the DRM other composer code base by checking if there was a disconnected display, not returning the error. And this was one of the problems. Another problem was there were, I don't know if you can see, but there were seg faults not pointing the references, but again related to CRTC, so creating the pipe to display in DRM. And in this case, looking at the code enumerates displays, but it does it regardless of their state. So the first connector always became the primary, and by adding some checks about the DRM connected state, again inspired by Jimbish commit, it was possible to boot. So this is one possible explanation about the problem. It comes from the Android source documentation, which says that the one primary display should be, let's say, hot plug immediately during initialization. Then there could be another external display, but I am not aware that it is implemented. And in fact, I saw there is an effort, let's say, to bring multiple displays in DRM other composer, which is ongoing. So basically, what happens is that the selected connector has no display attached, and while the connected is not brought in the path, let's say, in the pipeline of DRM. And so, in the end, we have the black screen. So other issues, let's say, observed, And with Nouveau, I will be very quick because, let's say, if we go through all of this, it will take all the morning probably. But basically, there are some problems with the software read-write buffers. So testing is sometimes not showing in overlay windows in Android. And there is I can see here, some shadowing between the layers. And with the latest hwcomposer 2 on Skylake, you can see here, there is some ordering problem with the cursor, or the cursor is treated as a normal primary plane and not cursor plane. But anyway, if someone of you, let's say, recognizes these issues and has information about how to solve them, so we will be very happy. So, quick recap. So Intel is booting with specific generation, having RGBA support in the primary planes. And AMD GPU is booting with Graphic Core Next second generation and later, because they have atomic support. And NVIDIA is booting, but has stability issues, so GUI restarts and GPU lockup. And the virtual GPUs, Virgil was working, let's say, already with our Composer 1, and VMware GFX still has some issue because we see no icon, black screen, but we will continue to investigate. So moving now, I will go more quickly. So in order to bring MDG support, the main, let's say, requirement is to have an LLVM version, which is compatible with the constraints of Mesa. And one important thing is that Surface Flinger has an RGBA pixel format constraint. So, in order to bring up android-x86 GUI on MG CPU, the gralloc DRM pipe backend is selected, and it was updated, the driver stack, and tested with Southern Island, Cayman Island, Volcanic, and Arctic Islands. So this is the history. I think we can skip it because we don't have too much time. But basically, with Mesa 18.1, LLVM 5.0 is required, but ASP code base just supports 3.9. So basically, the support for Radeon C and AMD GPU drivers would be lost. So these are, there are information, and you can have it. Let's say, have a look later. I will jump. These are details on how to update the building rules for AMKey, Android MK, and for Blueprint. But you don't need, let's say, to do it because it's already been done. They are available. And you just need one commit to revert. Let's say if you want to go back to normal, because we had to do some tricks in the module names and labeling, let's say, to be able to build concurrently the ASP LLVM version and the updated version. So I will be very quick on this. On ASP, basically the RGBA pixel format is the rule. And, in the past there were some chipset requiring BG array, also in the embedded world. And basically there was a workaround, let's say, with this label, which was the fallback to BG array in Surface Flinger, but then at some point it was removed. So in order to support hardware not having RGBA, let's say some kind of workaround or equivalent workaround is required. And the way, let's say, to solve it without issues with apps is to adding RGBA, RGB support when possible, let's say, directly at the level of a kernel DRM driver. So this is what happens without a RGBA pixel format. With hardware composer, you get an invalid pixel format and you cannot see the display. So in order to solve this problem, patches, RFC and patches were submitted to AMD GFX mailing list, and now have been merging in DRM Next. And this was a contribution, let's say, from me, but with the help of Alex Deutscher. Now, with the vulcanization, let's say, of android-x86, and some a quick look at the integration, initialization, some test results on Skylake GT2, and on supported GCN. Okay, some information on what you need to do. Also, what happened, let's skip it. In order to select Vulkan hardware composer layer module, basically you need to build to add the module to the installed packages and add a few lines in the scripts. And most important is to select the arrow hardware Vulkan property with the providing, let's say, the name for the specific hardware composer, hardware abstraction layer module. So let's keep this. These are some results on Vulkan CTS, and there were very good results. So a few tests were not passed. Let's skip this. Then during the test, a set of artifacts was discovered in the rendering with Vulkan. And the root cause was identified in the usage flag that were not yet implemented for the other composer buffer. And then by using MiniGBM, let's say, as an inspiration reference, they were added, and let's say the problem was solved. This is the V1 benchmark, which had, say, before with issues and then with a solution. This is a list that may be helpful for people testing about Vulkan and Android-enabled apps and games. And these are some issues happening with the 3D mark. Some problems so here in the shaders, orange and black. But so we know which, let's say, driver family is affected, but in this moment, I don't know if it's a problem of unsupported compression formats in information, let's say, in the content for the shaders, or a problem in RV. So the next steps regarding Vulkan are there is an error, publish the release, and let's say I am available for any inquiries, most probably also later in the day. So I don't know if you have time for many questions.
Any question?
And the demo, let's say, maybe you don't know, the demo already started, so because we projected the presentation using PowerPoint, running on Android x86 with hwcomposer 1 stack. And here we have a laptop based on Mullins, which is running hwcomposer 2. And in this moment, there is not much time, let's say, to run. If you want, we can run a Vulkan test. This one is on AMD. And I won't be very frank. This was tested and it should not crash, but let's see. And while on Mullins, which is has some issue with this particular benchmark, is crashing when the Vulkan API is tested. But it seems a problem related to GPU VM fault 146. So I'm not masochist. I will show you. I am masochist. Sorry. Okay, I stopped that also here. Sorry. I'm sorry. When I tried this morning, it was running, but probably not every time it's the same. So I've seen this test complete, let's say, many times. And by the way, as an information, the Android GUI also may be affected from being installed on flash drives, which I'm using to test. But what I've seen, it is quite stable, so it may freeze for a few seconds, but then you... Sorry, no, it's not going. Okay, let's stop here. It's strange because at times it completes, then in others not. Yes. So this is AMD Mullins. I'm trying a Vulkan-enabled application. Okay, there is some lag here. You can see. Not very good at this game. I always get killed. some other. This one should be a good one. Okay, this is one of Sasha Willem examples. So the Vulkan gears. Okay, I think that can be all. Sorry for the the crash of the former application. It was not intended to happen. But I like to be very transparent, so it's not yet ready. I say it's a work in progress. So forgive me. Have a nice day.